welcome back. So, in this session we will be talking more about the generalized function, or I would say generalized consumption function. The idea is that the 2 period model of consumption that we have understood, the 2 period model restricts some kind of it helps you understand the behavior of agent in the intertemporal framework, but in some cases, for example, if you are going to work out with the life cycle theory, Modigliani life cycle theory, or the Friedman's permanent income hypothesis, that you try to assume that the individual is living for some periods. For example, he works for 30 years, 25 years, or maybe the 35 years scenarios. Then if I have to go for the calculation of consumption, so his lifetime consumption, that how much he is having the consumption, then that matters a lot, and then it gives you the overall framework. So, if you read these days the journal papers appearing in the macroeconomics journals, they talk a lot about the lifetime consumption of the individual or the representative agent. So, the micro analysis helps you understand the 2 period in a more context way. So, we have moved from 1 period to 2 period. Now, we will be seeing the infinite period scenario, how when we extend the individual's consumption for infinite period, suppose period t, then how the budget constraint of the consumer looks like, how the utility function of the or lifetime utility function of the consumer looks like. So, here we will be trying to understand, and we will try to drive with simple exposition. So, the reference remains same. So, both here we have the for this particular lecture we are going to rely more on the Eric Sims, especially on his the consumption chapter, because that particular chapter is really good to understand the concepts. So, let us start with the basic exposition of the model. So, I hope the uncertainty that we just discussed, it helped you understand the idea of precautionary savings, that how precautionary savings have a role in the economy. So, let us start. So, multi-period setting helps understand about how consumption and income can be calculated over the life cycle. So, when I say in your macro textbooks, you will be reading about life cycle theory of consumption. So, how do you decide, how do you calculate that the life cycle consumption theory? So, we now assume that the household lives for many periods. So, here you have t, t plus 1, t plus 2 and t plus t. The lifetime utility can be written as u u c t plus beta u c t plus 1 plus beta square u c t plus 2 plus beta t, here you have u c t plus t. So, here this polynomial order that we have, it goes up to beta t u c t t. Now, we can generalize this and try to write the expression in this way. So, we can equivalently write lifetime utility using the summation operator. So, here it will be u t summation j is equal to 0 beta j. So, j is this, the polynomial order that we are going to decide, u c t plus j. So, this is the lifetime or life cycle consumption of the representative agent is going to look like. So, this is important to note, that how this particular representative consumer is going to decide about. Now, so from the utility side, it is more like a clear case that the behavioral coefficient is going to have the polynomial order. So, it is order is increasing with the increase in the period, the subsequent, or with the addition of the subsequent period. So, this is how it looks like. Now, let us work out with the budget constraint. So, when I say about the budget constraint, so let us work out with the first period. So, what we had assumed when we were discussing about the 2 period scenario. So, this one was C t plus S t is equal to y t, right. Then here we have C t plus 1 plus S t plus 1 is equal to y t plus 1 plus 1 plus r t s t. So, this is how it looks like. So, this is the current period, which means that if individual is going to have the income y t, he is going to consume some amount and some amount he is saving, right. So, in the future period what it becomes, So, here it becomes that if he is going to get yt plus 1 income, then this is again is going to be bifurcated into 2, which is ct plus 1 plus st plus 1, and whatever saving that he has made here st, this is going to be interest rewarding. So, he will be getting some extra income on the saving attached, which is equivalent to 1 plus RT. If I go on adding such type of phenomena by, or if I go on updating this particular equation with the period, subsequent periods, subsequent future periods, right. So, if I go on updating this, then this is how it looks like, that in the future period we had these two, then subsequent periods. So, here this particular individual will be saving again, because in 2 period model we allowed the individual to save only in the current period, not in the future period. Why? Because future period was the terminal period, because then you do not have any option, the only thing that you have to exhaust everything, you can't save and dispose. So, this is how, but now when we are saying in a generalized framework, then this individual can save in period 2 also, period 3 also, period 4 also, till the terminal period t, and before in terminal period t he will not be allowed to save. T minus t that we have, so t minus 1, that t plus t, t plus t minus 1, this we have. So, before the terminal period, 1 period he is allowed to save. So, his saving goes till t plus t minus 1. So, minus 1 is the previous periods, the 1 year before the terminal period. So, if he is going to die in 70, so he can save till 69, 70th year or 70th year he is not going to save anything. So, let us understand that also. So, here we have C t plus 2 plus S t plus 2 is equal to y t plus 2 plus 1 plus R t plus 1, here we have S t plus 1, here we have the C. So, here, so S t plus 2, so now he will have 1 plus R t attached with S t plus 1, and similarly in the final period when he is going to be in the terminal period, what he will have? He will have C t plus t is equal to y t plus capital T plus 1 plus R small t plus capital T minus 1. So, this will be the interest income that he is going to get before the terminal period, just immediate before, so immediate past you can say, before the terminal period, and then he will have the saving. Now, suppose we assume that interest rate is constant across time. So, we are not going to change. So, till the period t the interest rate is same, not much change. So, this is how it looks like, right. So, your S t t plus 1 minus S small t plus t terminal period capital P t minus 1, this is how it looks like, that here we will go for C t plus t upon 1 plus R, and this can go on. So, saving can be written in this way, right. So, this is how it looks like. If you walk this out backward, then here it looks like that C t plus t minus 1 plus S t t minus 1 is equal to y t plus t minus 1 plus 1 plus R S t plus t minus 2. So, one period before we can introduce it here. So, here I am having t minus 1. So, here I am going for one more period. So, in the same way, if I go for solving this, so here we have S t plus 2, S t plus t minus 2 is equal to C t plus t minus 1. So, this 1 plus R, it will be divided to all. So, what is the meaning? Meaning is that just one period before of the terminal period. So, this will be the present value. In terminal period, this will be the square term, because we already have 1 plus R here, right. So, this is how it looks like. So, the 2 period back, if you look for the savings that we have, so S t plus t minus 2. So, one period before this, the terminal period. So, this is how it operates, which means that your consumption and income both will have the similar characteristics. The only thing is that the terminal period C t plus t will have the polynomial if you are going to work out with the this saving scenario t S t plus t minus 2. Now, if you go back further, then this is how it looks like, that C t plus t minus 1 plus S t plus t minus 1 and y t plus t minus 1 plus 1 plus R S t plus t minus 2. So, S t plus t minus 2 is equal to C t plus t minus 1 upon 1 plus r, and this expression we have already got. If we just try to work it out further with this particular scenario, right, backward, and if we can repeat this and go to period t in this period, go back again. So, if we go back to period t, so this is how it looks like, that C t, it forms some kind of a pattern, and this pattern helps you calculate the lifetime biot constraint of the representative consumer. So, here we have C t plus C t plus 1 upon 1 plus r, here we have C t plus 2 upon 1 plus r whole square, and it goes up to C t plus t upon 1 plus r is equal to y t plus 1 upon 1 plus r plus y t minus 2 upon 1 plus r whole square, and it goes on. The idea is that if you get back here, the idea is that first we are saying that to what extent the individual can save, what will be his saving, and given the income, the interest income attached, what will be his saving. If I am looking at the saving, that how much he saves given the terminal period scenarios. So, this is how is the savings of individual look like in the period 1, and if you go back further, then this it looks like. If you go back till period t, then we will have a such type of pattern appearing. So, once we have such type of pattern appearing, then you can see that this is the lifetime consumption of the representative agent, and this is the lifetime income of the representative agent. We have not introduced any tax here, it is just the income and the consumption. So, the subscript t plus t, it is representing the time period, it is not representing any kind of tax. So, subscript is the subscript originally. So, here if you try and see that how does it look like. So, here it is max C t plus 1, it goes up to C t plus t. Here you have the utility function, here you have a t summation j is equal to 0, here you have the beta j u C t plus j, subject to, you can write this particular expression in short form in this way, right, by using the summation. So, t summation j is equal to 0, C t plus j upon 1 plus r j is equal to t summation j is equal to 0, y t plus j upon 1 plus r j. The Euler condition can be written as the marginal utility of the future consumption, right. So, here if I am mentioning about j, so marginal utility of the consumption period t plus j, it is equivalent to the beta into 1 plus r, the marginal utility of future consumption, it goes up to t plus j plus 1. So, you can say that the current period consumption of individual is nothing but beta multiplied by the savings that he is making in the current period. So, this is what is the same. So, at this level, this is the Euler condition. So, this is the generalized Euler condition of the representative agent. So, as compared to what we saw here in the 2 period scenario, in the 2 period scenario we had a Euler condition of, we had the Euler condition going to this particular scenario, here we had. So, here we have the Euler condition scenario, you can see this, right. So, here we have. Now, if I am going to see with uncertainty, the Euler condition changed and Euler condition became expectation of C t plus 1, right. So, this is how we had added. So, this was the Euler condition of the representative consumer when he is facing uncertainty in the future period. When we are going to generalize it, that how it looks like. So, your generalized Euler condition looks like this. So, you can go for maximization with respect to C t plus 1 and C t up to t. With this biot constraint, you will be getting mu transpose C t plus j is equal to beta into 1 plus r mu transpose CT plus J plus 1, which is the marginal utility of future consumption, and here you have the marginal utility of current consumption. The marginal utility of current and future consumption are same provided that the individual saves in the current period, and this is equivalent in the future period. It becomes 1 plus R. Beta is your behavioral coefficient. So, this is how we try to look at. But as we have mentioned in the previous analysis that this particular exercise is not, this is the dynamic optimization condition, the Euler condition. It just says that the whatever individual consume in the current period, it is equivalent, he is indifferent if he saves that and consumes in the future. So, both are same, but this cannot be the consumption function. So, in order to derive the consumption function in the lifetime, you can go and substitute the budget constraint into this. So, you can formulate the log function of the consumption, whatever expression you get, you substitute back into the budget constraint. What you get is this, that if you substitute the generalized Euler condition back into intertemporal budget constraint, which means that you can solve this and put it here. So, here it should be log. So, here it will be 1 upon C plus T plus J, here it is 1 upon C plus T plus J plus 1, right, and product of 1 beta into 1 plus R. If you substitute back here, you get the consumption function in the same way that we got, and with that you can calculate the lifetime marginal propensity to consume of the individual, the lifetime marginal propensity to consume of the consumer with respect to future income, with respect to current income, with respect to interest. The same kind of strategies we had adopted. So, maybe I think it is here I am talking, if I am talking, then I am talking about this, that we can derive the, so your CT is equal to, CT is the C function of YT plus 1. So, I am talking about this derivation. So, you can go for deriving the similar kind of derivation here. So, here this is how it looks like. So, here it makes sense. So, here if you just try to substitute, so this is the consumption, this is the income of the, so this is the budget constraint. If you try to work out, so here we have the 1 plus R upon Rj, after solving the C bar is the outcome that you get it from the substitution, and this becomes your Yt plus J upon 1 plus Rj. If you just work out with this, then it becomes 1 upon 1 plus alpha. So, as long as the t is sufficiently large, so if you work from one number of years, then you are going to get the alpha t, the plus 1 is equal to 0, right. So, overall what appears that in the life cycle, so it becomes, if you try to work out, then it becomes the R upon 1 plus R plays very important role as compared to 1 upon 1 plus beta that we got in 2 period case. Here the rate of interest will matter. So, R upon 1 plus R will matter, and if you substitute it further with respect to, if you go for partial differentiation with respect to future income, the expression will change. So, the underlying idea is that with this life cycle imposition or life cycle derivation of the utility and the budget constraint of the representative consumer, we can easily see that how much this representative consumer is going to have the consumption, the change in consumption with respect to current income or I would say lifetime income. So, here there will not be any kind of future as such, but yes, if you want you can add t plus j plus 1 and you can calculate, but your lifetime consumption depends upon the rate of interest, how much you have the rate of interest, and the earnings will decide about that how much you are going to save. And if you are thinking about the giving preference to the future, so beta is continuously going to be higher, then you are going to give more importance to the future period. So, that works. So, generalized equation of the optimization, this is how it looks like. So, I hope it is clear to all of you that the consumption function that we normally see in macro textbook, whether it is Keynesian, whether it is the life cycle of Modigliani, whether it is the here you have the permanent income hypothesis by Milton Friedman, all these theories can be explained with the help of simple mathematical exposition of the macroeconomic concepts, and this macroeconomic background will help you understand these theories in a much better way. And you can also extend this further with some more additions, and you can see that how those additions will help you understand not only the consumption, but also the savings. For example, we introduced the uncertainty, and we saw that how this uncertainty, when we introduced into the model, it helped us understand the precautionary savings. So, to summarize, now we will be moving to the government, and we will be seeing that how in the 2-period model setup the government is going to react with the set of individuals, talking about when the individuals pay the tax to the government, how government reacts to that, how government tries to finance the expenditure. So, those concepts will be important. And in this consumption, if you go by one by one, so we started with 2-period, then we started some kind of, we derived the consumption function, when then we looked at the comparative statics, introducing the income interest rate scenarios. Then we introduced the uncertainty, and uncertainty added further dimension of precautionary savings, and then we generalized the consumption and budget constraint of the representative consumers in a more robust way. And then we can see that with this generalization you can superimpose the condition of life cycle theory and see how the permanent income hypothesis, that how individuals will behave when they are introduced to this, whether it will be behavioral coefficient playing very important role, or it will be the reward of the representative consumer. It also allowed us to impose the condition that if we are allowing the individuals to save in the subsequent periods, then how the budget constraint of the representative consumer is going to be changed. So, I hope such background will help you understand the recent developments in macroeconomics in a much better way. These are the new classical ideas. So, new classical ideas have such type of understanding that they added a dimension of the macro foundations, and we will be having different schools of economic thought, and under that we will be coming back to this again, that how and from where this started and how it is exploring, how it has been explored in the recent literature. I would request all of you to have a look at some of the papers appearing in macroeconomics literature, mostly from Journal of Macroeconomics, Journal of Economic Dynamics and Control. So, these journals have a sufficient background about such formulations, and then you can easily understand, at least you will have idea about that how this particular mathematical formulation helps, and in which all areas such foundations, macro foundations are applied to understand. So, people try to understand the behavior of the consumer, behavior of the representative agents, behavior of the individuals in a group when we superimpose the condition of rich and poor. So, all those dimensions are covered. So, I will be stopping it here, and then I will be starting a new topic which is about the government. So, let us have some kind of background about the government, and then we will be seeing that how governments react to such type of formulations. So, now we are going to talk about the Ricardian equivalence. Now, in the 2-period model, we can also introduce the government, that is the flexibility that it provides, and since the mathematical treatment becomes more simpler in 2-period scenarios compared to infinite period or up to period t. So, we will be understanding that how individuals react to government decisions, whether those government decisions impact the consumption behavior of the representative agent. If those actions of the government are going to impact, or if the government is going to give some kind of tax relief or tax burden on the individual, then how these individuals are going to play important role, how these individuals are going to work out with their consumption. So, whether the consumption is smoothing pattern will remain same or it will change. Now, I think those dimensions are important to look at, and since you already have the background now, it will be easier to understand. And the idea behind Ricardian equivalence, if you see in a nutshell, it talks about how individuals react to the change in the government decisions about taxation. The concept starts with the basic premise that if government is going to give you tax relief in the current period, it doesn't mean that it doesn't mean that you will not be paying in future. The government also goes through the same framework that we have seen for the consumer, that it also optimizes its expenditure. So, maybe in the current period the government is going to reduce the taxes, but in future period the government will increase the tax. Now, individuals are also rational, so they also have the similar kind of experience, learnings, and then they also have certain expectation. So, if the government is going to give a tax relief in the current period, then individuals are also smart. They know that we are going to get we are getting the tax relief in the current period, but we are going to pay this in future. So, they also save this amount to smoothen out the burden of tax in future period, and then they easily smooth out or smoothen their consumption in 2 period scenarios. So, Ricardo in the late around 17 or I would say 18th century, he talked about the such type of behavior of the consumer when the government is going to take decision about the taxation. So, here it is also, this concept is also linked with the public finance theories, public economics also, but it is more of a macro because it deals with consumption and all other variables, but you can also link it with the public finance. So, the Ricardian equivalence tells that the tax cut is not a free lunch, you will have to pay back in future. So, we will be understanding those dimensions here, and we will be also trying to see that how this work. So, the reference remains same for this. I would request all of you to go through the Stephen D. Williamson book, and this book gives you the idea. You can also go to the Sanjay K. Chugh, and this also gives a sufficient background. So, what will be the learning objectives, that how the government behaves in the economy, what is the role, how government constructs the lifetime budget constraint, right, how we can understand the Ricardian equivalence theorem, how we can understand the burden of the debt and the financing strategies. So, these are this, but I will continue this in the next session, and then we will start from there. Thank you so much.